Hi guys, welcome to Tech Geek. So today we are back with the daily LEETCODE challenge problem. That's construct binary tree from pre-order and in-order traversal. That's a LEETCODE medium question. Now before beginning, I'd like to request you all to please like, share and subscribe to my channel. In case of any queries, interview experience, anything, do let me know. I'll be there to help you out. Now let's look at the question and what does it demands for and what we asked for. Okay, so we are given two arrays that's of pre-order and in-order. Where pre-order is the pre-order traversal and in-order is the in-order traversal, and using these two traversals we need to construct the tree. Okay, that's the approach we need to do. We have been given input and output. For his example, for this tree we have the pre-order and order. This should be the resultant tree, and they will check on their own. Okay, like whatever, how they need to validate the tree is built or not. Okay, so let's see how this question goes on. Let's take some examples. Okay, uh, I'll just take one example of in order. Okay, in order and pre-order, we have been given two things. One is in order and one is pre-order. Okay, so let's take this. Okay, first of all, before knowing, you must be aware of what an in order is, what's post order, right? So in order and pre order. Pre, as the word says, obviously pre refers to the value will come first. Let's say the value is C. So value, then left, and then right, or you can say root and then. And in order, it's left, then the root, and then the right. That's what we follow. No, that's what the concept we'll use. Let's look at some array. Let's assume that the in order traversal for a tree is 4, 2, 7, 5, 1, 8, 6, and 3. So we have been given an in order as well as a pre-order. So the pre-order for this tree is 1, 2, 4, 5, 7, 3, 6, and 8. Okay, so that's how we have to do. Just keep in mind the number of elements in the two arrays should be same. Okay, now coming to how we'll approach this problem. Okay, we have this, now we know the limitations too. Limitations, or you can say how the things are to be. That for this, a pre-order is first element, that's C. That's kind of a root, or you can say the value. So this is the root of our tree. Reorder suggests the very first value is root and followed by the left and right. In order gives the root comes in between. So we found the root. Now we know this will come in the left subtree, this will come in the right subtree of this particular root. Okay. So now using this we can even separate these elements came from right, these elements came from left. Okay, so let's construct the tree one by one. We got the main element, that's 1. Okay, now we got one left subtree and one right subtree from this. Now for both of these we again require one root. This root will again come from the pre-order. So the first element of the pre-order gives the root. Okay, now this is 2. So for the left subtree, the root is 2. as we get the root, let's write it. Okay, and then we look how things could go on. For the right subtree, the root is 3. The first element of the pre-order will give you the root. Okay, now again for this, let's check these values in order. Elements to the left will lie in the left subtree. So the left subtree of 2 contains only 4. Okay, so that's the only one, as it's 1, so I'm just writing it directly, otherwise we need to look into the root. So as it was also a root, so we'll just leave it. For the right subtree we have 5, 7 and 5. Now which particular is an element or is a root? So root is the very first coming is 5, so the root will be 5. Now 5 is the root, right? 7 comes to the left, so 7 comes in the left subtree. If 7 was that side, that's towards the right, that means it would have been the right child. Okay, now all these elements are finished. 7, 5. Let's look at the right subtree. We have 6, 8, 3 was our, yeah, 3 was our root. Now 6 and 8 both come in the left, so these are in the left subtree. Which should come first? The one following this pre-order. So 6. So the left subtree should contain 6. Now again let's check here. This comes to the left. Again this is a left child of this. And 8. So this is how the tree is constructed. So what we did is we took the first element of the pre-order. We'll search for that first element in order. Elements to the left of that element in order are in the left subtree. Elements to the right of that element uh, is the right subtree. Again, take that value as root. Now, we got the left and right. So, in order, we'll get the left and right too. For the following elements, that's 2. Again, we got the left root. For 3, we got the right root. Again, search for these elements. Find its left and right positions. So this is a recursive approach that goes on. Okay, so what is the thing you need to know? Every particular time you need to check the first element of the pre-order, search for it in order, check its left and right subtree. And again then for the left and right subtree we need to check for the root. So this process goes on recursively. I hope this is clear. I'll just give a short brief again. What we have to do is the first element of pre-order is the root. Take it as a root, followed by searching of that element and in order. The elements to the left lie in the left subtree, elements to the right lie in the right subtree. Come to the next element, that is a left subtree as it occurs here, 2. So 2 got the root. Again, in the right subtree, the first element was 3. 3 got the root. Search for these two elements, again get for left and right. Do the same thing iteratively or recursively, you will get the solution. Okay, now let's look at the solution. So the same thing which we did was searching for the pre-order and the in-order. That's why we are passing this indexes at 0, pre-order -1, in-order 0 and -1. So we are passing these two arrays to build. And we are passing a map. Map contains the in-order values. In-order values, that means in-order value plus its index. Okay, why the index? Because we were searching for the left and right subtree, so that's important to know the location or position of that particular element in the array. We'll check for the conditions. If we exceed the start, if we exceed the start with end, that means the traversal is completed, so we can end this. Okay, now creation of root, inserting it into the root, that's the very first element. Why? Because pre-order start is always a root, as said. And how many elements are left, that we can get with the starting point of root. For left, we'll go to the left subtree. Left subtree like pre-order start plus numbers left and in order start minus root minus 1. That means in order start with in order where we got the root -1. And for here we'll get This plus nums find. The nums is actually telling the number of elements in these left and right. Okay. The same way we'll go, and we'll go with this particular approach again and again. I hope this is clear. If in case there's something or the other that's missing out, something that you think is incomplete, or some other process you find is more accurate, you can go with it. But I'll prefer you guys to go up with the approach that you understand, instead of just looking into it and getting over that, yeah, this is the thing you want to go. So it's better you understand things and then go up. You could even do it with a set, that's a tree set also. That's basically up to you. Using stacks you can do it. There are various options that you can do it. So it's quite efficient, whichever you feel is right, and the time complexity is good to go. Okay, so I hope this is clear. If in case again you feel there's something missing out or anything, do let me know. For this, the time complexity would be order of n, as we are traversing each and every element. Okay, thank you guys. If in case there's any queries, do let me know in the comments.